Hello, my dear students. Today we are going to discuss about the numerical problem of brake. This is the simple numerical problem related to the simple bend brake. A bend brake acts on the 3 by 4th of the circumference. That means theta is equals to 3 by 4th of circumference of a drum of 450 mm diameter. That means diameter of the drum is 450 mm, which is key to the shaft. The bend brake provides a braking torque. TB is equals to 225 Newton meter. One end of the bend is attached to the fulcrum pin of the lever and the other end to a pin 100 mm from the fulcrum. That means B is equals to, or we can say that OB is equals to 100 mm. And if the operating force is applied at 500 mm from the lever, that means L is equals to 500 mm and the coefficient of friction is 0.25. Mu is equals to 0.25. Find the operating force when the drum rotates in the clockwise direction and anti-clockwise direction. So this is the solution, the given data. The diameter of the brake drum, this is the drum, and the diameter is given 450 mm, and all other data is also given. That means L is equals to 500, B is equals to 100. So we have to calculate the operating force P, that is when the drum rotates in anti-clockwise direction and clockwise direction. So we know that the angle of theta is equals to 3 by 4th of the circumference. Circumference, that means 360 degree. The theta is equals to 270 and change into this degree into the radian. So theta is equals to 4.713 radian. And we know that the T1 upon T2 equals to e raised to power mu theta. That means tension ratio of the belt. And also we know that the braking torque TB is equals to T1 minus T2 into R. We have already derived these two formulae previously. So by solving these two equation, we will have the value of T1 and T2 because we have only two unknowns, that is T1 and T2. We have the value of mu and theta. So we will have the equation 1 in terms of T1 and T2. And this is the equation, second equation. We have the value of braking torque. Substitute this value from given data 2225 Newton meter, or R is equals to 0.225 meter. So now we have the value of T1 and T2 in both the equations. So by solving these two equations, we will have the value of T1 and T2. So T1 is equals to this and T2 is equals to this, 444 Newton. Now for anti-clockwise rotation of the drum, we have the value of P. So now taking moment about point O, or we can see that this is the fulcrum. For the we have the value of P into L equals to T2 into B. So P into L, that means force into perpendicular distance, direction anti-clockwise, and second one is T2 into this perpendicular distance B, direction clockwise, and T1 into 0. So P into L equals to T2 into B. So L is equals to 500, B is equals to 100, and T2 is equals to, we have already calculated in previous slide, 444. So substitute all the values and we will have the value of P. The operating force P is equals to 88.8 Newton for anti-clockwise rotation of the drum. And for clockwise rotation of the drum, the equation, this is the for clockwise rotation of the drum, and the equation will be P into L equals to T1 into B. Here you can see that P into L and T1 into B, because if the direction of the drum is changes, then the T1 and T2 also will be replaced. So now we will have the value of P is equals to 288.8 Newton. So this is the simple numerical problem. So thank you.